In order to get the entire titration curve, we will like the system to do its work. So leave everything untouched, just like the system run its own course. All right, and it looks beautiful. And then just keep going, keep going, keep going, keep going. Beautiful. We have about 10 seconds. All right. It's already 255, 8 and 6 and 1 and 4 and 7 and 260. It's gone. All right. Now, when the system is to the end, and then we're going to stop our titration, leave everything here.
As indicated in your lecture graphs, the x-axis is the volume of your titrant. However, we have used time to program the LabQuest graph. Keep in mind that usually there are about 20 drops in every milliliter. And if you set the drop rate to 1 drop per second, you can see the similarity.
All right, in the back of our system, and then there is a pointer. Take it out, equivalency point. All right, so now at the equivalency point, we have our pH, I, J, K. Now we're going to see at the pH equals 9, which is K. All right.
After taking the observations, we will proceed to exploration 2.
Keep our titrant as our sodium hydroxide. All right. So what we're going to do is simply refill our burette with the sodium hydroxide. And of course, slowly but surely, and then lower the meniscus all the way to our 0. Beautiful. All right. Now, because we're going to switch the system, so we have to keep the integrity of the solution, and then we wash, rinse our system, and clean. Okay. So now, we're going to change from strong HCl to a weak acidic acid. So same thing we will do. And to rinse our system, pipette with our acid and let it draw.
After properly rinsing it, we will pipette out 8 ml of acetic acid.
Now, beautiful. And return. Okay. Yeah, you see, there's still some. We don't care. Going to. Now, we do exactly the same, about 100 milliliter water. So just enough to have our whirlpool. Right? All right, now the whirlpool start up, and then we're going to turn it slowly but surely, and then lower our pH meter into the system. Okay, very well. Because we're going to use exactly the same programming, I will just hit the file once, and then we'll do the second run, and then that's it. All right, save some time, and then that's all. The acid system changed from strong acid to weak acid, and then now your pH is increased, and so that only means that our system works just fine. All right, so now make sure hit your stop button once. Now the graph starts, and then remember 1 drop per second, 1 drop per second, 1 drop per second. Blah, 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 blah. Oh, I just remember what happened. Clear colorless base, clear colorless acid. Now, at the very beginning, you can do this, all right? So, 1, 2, 3. Don't ever forget to have your indicator. But at the end of a class, you will be asked, well, is that necessarily? All right, so we just like the system. Oh yeah, look at that. You should expect a significant change after 8 milliliter, right? Whether it's a system. Oh, all right. Ooh, see, it's early. Now significant change. Now you can see the curve start tilting up. Very well. Almost. Yep. Beautiful. And 4 and 7 and 0. Now we're done, right? So now we will turn off it and close our ball and we finish.
The equivalency point is the most vertical point on your graph.
And let's see if we have 9. All right.
We will now move on to the second part of exploration 2.
Base from strong to weak as well. Okay, so now, beautiful. First, we're going to change our acid.